Okay, I think we're going to go ahead and get started. Thanks everybody for joining and welcome to Security Testing Mobile Apps with viaLab. Before we get started on the actual topic, I wanted to do a brief introduction of myself and viaForensics, then go through just a couple of slides before we dive into the live demo. Just so you're aware, everyone's lines are going to be muted. However, at any time throughout the presentation, you can submit questions or comments through the chat window. At the end of the demo, we're going to try to answer as many of those questions as we can. My name is Katie Strumka, and I'm the manager of mobile services at viaForensics. I'm responsible for our day-to-day mobile security assessments and have also been very involved in the R&D that was done in order to develop the product that you're going to be seeing today. For those of you who have not worked with us in the past or attended any of our webinars or trainings, viaForensics is a mobile security company that was founded in 2009. We adopted an early focus on mobile forensics and have actually been doing security testing since 2009. We have about a 10-person team dedicated strictly to mobile device research, mobile device and application security research and development. And we've done a significant amount of R&D in this area and have used this information when performing our own mobile security assessments, as well as developing our own forensic and app security products. The focus now is on providing tools to help enterprises and government do this kind of work effectively and efficiently. The purpose of the anatomy of a mobile attack slide here is to demonstrate that there are multiple layers that really should be protected in order to prevent a mobile attack. Of course, there's the device, which contains your personal information, company-sensitive data, and your third-party downloaded apps. But other areas of equal importance include the network that the application data is being sent over, as well as the back-end web server that the application communicates with. In both our AppSecure mobile app assessments, as well as in our viaLab product, we not only test the app itself, but each of the other attack surfaces that are shown on this slide as well. Just a little bit of history here on how viaLab came to be. Our AppSecure service is a manual app security assessment and typically takes anywhere from 60 to 80 analyst hours. And so after doing quite a few of these over the years, you can imagine the amount of information that was learned. Because these assessments were so time-consuming, we realized that we were limited in the number of assessments we could perform. So in order to keep up with the growth in mobility, we either had to hire more people or begin to automate the process. So with the development of viaLab, we realized that not only could we increase the number of assessments completed, but we could also provide this as an option for our clients to perform this testing themselves. And looking at the life cycle of a mobile app up on the slide there, you can see that viaLab can be used to test an application at various stages. An app developer can quickly run the automated test to find the low-hanging fruit. This might include password storage on the device in clear text, or the app being susceptible to a man-in-the-middle attack. Whereas a security team can do a more in-depth assessment. In either case, the summary reports can be passed along to audit teams or CISOs to demonstrate these findings. To reiterate some of the key benefits that viaLab offers, it allows us to perform a thorough security assessment in less than an hour. The process is repeatable and the license allows for unlimited testing. So what this means is that for every app version update or operating system version release, the app can be reassessed to ensure that new vulnerabilities were not introduced. You're going to see during this demo that viaLab performed automated tests which produced risk ratings. However, the analyst is ultimately the one who decides whether or not that particular item is really a risk. Finally, there's an integrated reporting feature which not only highlights the findings, but also includes recommendations as well as mappings to the OWASP Top 10 and common CWEs. Okay, so moving towards the demo here, Unfortunately, since you can't all be here to see the physical setup of viaLab, I'm going to do my best to describe it before kicking off the actual live demo. I'm using a laptop which is running our Santoku Linux virtual machine with viaLab software installed. Connected to that laptop is an Android Nexus 4 device, as well as a Wi-Fi dongle, which will be used for the network testing phase of the assessment. Okay, bear with me for a second while I switch over to the VM and give my status bar a second to drop down to the bottom. Okay, while we're waiting on that, I'll give you a quick overview of the main windows within viaLab. This is actually an open project. The app we're going to be testing today is the any.do application for Android. It's just a simple task manager, and we actually really appreciate it because they tend to show off the features of viaLab pretty well, as you're going to see throughout the rest of this assessment. So that's why we chose this app. It's nice to show all the different features and functions within viaLab. At the top here, you have the status bar, which is where you're going to create, open, save projects. One important item I wanted to highlight here is the agent. This is our viaLab agent that we have installed on each of our test devices. So right now it's installed on the Android device that I have connected to viaLab. And this is our custom-built agent that allows us to communicate more directly with the device in order to get the greatest amount of recovery. Clicking there just refreshes the agent, and here you can see all the different functionality that it has. It can display device information, apps installed on the device, running processes. Let me log in here and so you could see the screenshot feature. It will take a screenshot of what's displayed on your device and pull it into viaLab, among many other functions which we're going to show throughout the testing of viaLab. I want to also point out the options menu on the upper right-hand side. This is where you're going to find logging details. You can go into preferences and set your name, company, the Wi-Fi network name and password you want to connect to, as well as a logo. If you don't want to change that for every report, you can just put in a custom logo in the tab that's going to be automatically included. viaLab updates are also going to be done here, and there's also a feature to back up a project or import a project in case you want to save it on an external drive or something along those lines. Finally, the help menu is up here. So, at any point throughout the assessment, if you're stuck on a step and not sure where to go, there's step-by-step guides for each of those sections, as well as troubleshooting questions. As far as the rest of the interface, on the left-hand side here, you can see this is your workspace area, and this is where all of your findings and resulting artifacts are going to be displayed, as I'm going to point out throughout this demo. The main screen in the center here has the different tests that are going to be run. We have a Setup tab, a Network and Web Assessment tab, Forensic Analysis, Code Analysis, Advanced, and finally the Report Editor. Again, we're going to be stepping through each of these, but across the top there are the actual tests that are going to be run on the device. And then down at the bottom here is your editor pane. And this is where you can create new findings, or an analyst can override existing findings, modify them, create a screenshot, things of that nature. So moving forward with the demo, step one is to select the application. So at this point, the application should already be installed on the device. From the drop-down here, you could see all of the different applications that are shown on the phone. We selected the any.do app, provided a description, and when you click Download App Data, it's going to download the application directory from the phone and pull it into viaLab to do analysis and comparisons at a later date. Clicking forward will bring you to the Setup Wireless Network step. Here, this is going to launch a Wi-Fi connection using that Wi-Fi dongle that I mentioned in the previous slide. It's an internal connection that allows us to perform our network tests, including man in the middle and SSL proxy. So the first time you launch this on your device, you will need to click the button and go to the settings on your phone, select that Wi-Fi connection, and it should connect. I'm doing that right now on the phone. I'm going to app settings. Connected to a different network right now. Of course, you know, something has to go wrong in a live demo. Once it's connected, it always connects right away and gives you that okay. Okay, I'm going to move forward from this step. We can come back to this once we're able to get that set up. But since this application is already pre-populated, we can still walk through all the steps. The general information tab here is where you can enter different search criteria, and this is one of the key features within viaLab. It allows for automated searching of log files, data files stored on the device, PCAP files, and memory dump later in the code analysis section. So here you can select the type of search criteria you want to add. On the right-hand side here, you can see that we already added the username, the password, some keywords that we know have already been populated within the app. And then another key feature here is that it does regex expressions. And so we selected social security number, and so it's going to search for that pattern throughout the rest of the assessment. You can also flag any of these search criteria with any of these compliance tags, and these will be displayed in the final report. This is the login and data population step, and this is a very important step. Once you hit begin login process, what it's going to do is it's going to begin capturing network traffic and log files, and the analyst at this time would sign into the application and use all of the different features within the app. So for example, if it's a banking application, you would want to make sure that you sign in, you check your accounts, you initiate transfers, maybe do a check deposit, test all of the different features, because at this point we're going to be capturing all of the network traffic that will later be searched for in the assessment. Once that's complete, you would hit forward, and all of that search criteria that you entered in the previous selection is going to be automatically searched for upon clicking forward. Once again, because I have this all pre-populated, I'm not going to do it again, but here you can see when I clicked forward, it searched for those items and it actually found all of them. It found the username, it found the keywords that I had entered, it found the password, and what looked to be a social security number. By double-clicking search results and zooming in, you can see where all of those were found. Let me expand this a little bit here for you. Up at the top here, it shows that all of these values were found, and this is the location on the device that they were found. So when we get to the forensics tab here in a few minutes, we're going to show you that in the databases directory and the data SQLite database, all of this information is stored. So this is something that we want to look at right now, but probably dig into a little further once we get to the forensics tab. While we were capturing network traffic, we also searched that file for our keywords as well. And here you can see in plain text, without any type of encryption at all, that was actually one of the tasks that we had added into the application. This one as well, and then here was what looked to be like a social security number. I had mentioned earlier that the analyst has control over what is actually a risk or not. If the analyst digs into this file and determines that this isn't a social security number, it just happens to look like one, well, they can go back and they can modify that risk rating to something lower or maybe to a pass. So for example, if I double click on found social security number here, I can see that viaLab automatically flagged the keyword as medium risk. Let's say it was not a social security number. You can change it to pass, hit save, and it's reflected up on the left-hand side there. It is important to keep in mind that there's an audit trail of this. So if an analyst decides to change all those, that will be tracked in the audit trail. Moving on to the network and web section, the Nmf Scan is the first step that we do. And what this does is just a simple scan of the ports and services that are open on the server that is selected. Because we do not own the server or have permission to do the assessment, we're not going to do this scan right now. But from this drop-down menu, you would select the server that your application is communicating with. And then you can select either a light, medium, or intensive scan. Intensive, obviously, would scan for the most ports and would likely be reflected on the server. Somebody monitoring that server would notice it. You hit Run Scan, and the results will be displayed on the left-hand side. For now, though, since I do not have permission to do that, I'm going to skip this step, and I'm going to move forward to man in the middle. Again, man in the middle, similar to the data population step, you would hit begin man in the middle attack, and at that point, the analyst would log into the application and see how it reacted. Once again, since this is pre-populated, I'm going to show you what happened. It does say that man in the middle failed, so the application continued to log in. It did not prevent the user from logging into the app during this attack. And in the meantime, viaLab was able to intercept all the communications sent to and from the app and the server. So here, if you expand all this, you can see the username and the password. And you can see a lot of other details. If you scroll down through here, there's email address and the tasks as well, if you dig a little further. viaLab shows those search results, and we also took a screenshot during the man in the middle attack to show that, hey, here's the app logged in. It did not throw up an error preventing the user from signing in, and we want to capture that in the report. So that's the screenshot that we took of the Any.do application. If you want to know a little bit more information about the man in the middle attack, you could actually go into the raw artifacts up here. If you expand artifacts and go into man in the middle database, by double-clicking this, it's going to open up our artifact viewer. Any of those artifacts that you see can be opened in an artifact viewer and viewed in their native form. So here you can view in a SQLite manager. Otherwise, we display it here in the table format. Clicking flows will show you exactly what was captured during the man in the middle attack. I'm not going to bore you guys by going through each of those records, but if you did want to see every piece of data that was intercepted during that attack, you have that capability through the artifact viewer. So that was man in the middle. SSL strip is a related attack that it attempts to downgrade HTTPS traffic to HTTP in order to intercept data in clear text. And in this case, SSL strip actually failed as well. Once again, the screenshot shows us that the application continued to log in through this attack. And if we double click up here on the artifact for SSL strip, we can see all of the data that was intercepted during that attack. Now, once again, I pointed out before that the analyst can review this information, and here it looks like only the device information. There's a UDID, a device identifier, MAC address. It looks like the information that was intercepted is actually limited. So in this case, I might actually want to double-click on the SSL strip finding and maybe just put it as a low risk. It didn't have my application data or my password, so I'm just going to go ahead and save that and make it low risk. The final step in the network and web section is SSL proxy. Here, a root CA is installed on the actual device, and we're testing to see if the application is going to trust that CA and allow us to intercept all traffic through SSL proxy. In this case, it says that the encrypted network traffic was exposed during this test, and that is likely because the application was not performing certificate pinning. If certificate pinning is not performed within the application, then we're able to successfully intercept SSL proxy traffic. By double-clicking on this output here, you can zoom in and you could actually review all the requests and responses that we were able to intercept. I mentioned earlier in the introduction that viaLab can be run at various stages by the developer, by a security analyst. When I said that a security analyst could dig a little further into some of the artifacts rather than just doing the automated test, this is a good example of that. A developer might not know what to do with this kind of information, but a security analyst could jump into the artifact viewer and dig a little further and review all of the requests and responses and see if maybe they would be susceptible to additional manual attacks. Once again, that keyword search criteria that we entered earlier on is automatically searched. And here you can see the username, URL and code, we searched that as well, but also the username in plain text was recovered, password, and then the keywords. So pretty much everything that we recovered stored locally, we could also recover here. Okay, moving on to the Forensics tab. This is the only tab or test, I should say, in viaLab that does not provide an automated test for the analyst. This simply recovers the application directory from the device and allows the analyst to dig into the files as though a forensic examiner would. So it has all the application files stored here. During our app secure assessment, we always go through each and every file to look for all data that could possibly be stored. But to speed up this process, I'm going to jump to the file that we had found up in the setup within the search results. So here it said that username and password was stored in /databases/data. So I'm going to jump straight there. I can see that this is a SQLite database. And expand this window here so you guys can see it a little better. And then I'm going to go ahead and search any due task history. And here is all the information that we saved within the app. So every single task. It looks like we have, these are the social security numbers that the search criteria had found earlier. Looks like we have some tasks here as well. Pretty much anything that you enter into the app is stored in this database. And this is actually not uncommon for a lot of the applications we see. We see this information oftentimes stored in easy to identify tables and unencrypted. So as I mentioned earlier, within the editor pane, you can create your own findings. So let's say I want to show that all of the tasks are stored here. I would probably double-click data and open in our artifact viewer again. Click on task history, and maybe I just want to select the first 5 or 6 here and select output. That's going to automatically save that output on the left-hand side here under the Forensics tab because that's what I was under here. It's going to save it in this output section. And I could label this as test saved in database. And associated with that output, I might also want to create a finding. All app data stored in database. And then you can save it as high risk, medium risk, low risk, whatever you deem necessary. And that automatically gets populated on the left-hand side there. Okay, clicking forward, moving on to the code analysis step. The general inspection here is basically going to run a list of automated tests against the Android APK itself, the actual app itself. I'm not going to click forward because I already did, but here's the list of all of the tests that it actually runs. It checks the application for code obfuscation. It lists different activities, content providers, checks the application certificate to make sure it's valid, all those other items that are mentioned there. Once you click forward, it takes less than a minute to complete, and all of your results are shown under the code step here. Some of it is informational, some of it has actual tests and findings associated with it. For example, here's your app certificate. It checks the date, and here you can see that it found that the date was valid. It lists vulnerable content providers, checks different permissions, things of that nature. At any time, you can click, let's say you find some output that's too large maybe and you don't want to include it in the final report. This isn't all that large, but let's say we want this in the appendix instead of within the report. You can click on that item, click on the A down here, and it's going to send it to the appendix at the bottom here so that it's not bulking up your report when you review it at a later time. The next step for code analysis is the memory dump. When you click execute memory dump, that's actually going to dump all the device memory into this artifact here. You can see it's labeled with the date, and that's the memory dump file right there. And once you hit forward, it's once again going to perform those keyword searches using the search criteria you entered in the setup tab. And here we can see that everything once again was found in the memory dump: username, keyword, password, and the social security number. So double-clicking memory dump here, we can zoom in and it highlights all of those keywords. Another option is to double-click that memory dump file, and it's going to open in an artifact viewer. And you have various views here: hex view, you could run strings against it. So let's say you just want to do a quick search for the password. We know it was found, but let's just do a quick search to double check. This is actually a very large file, so it takes some time to search for that word. While we're letting that run, I do want to, since I'm demonstrating an Android application, I do want to talk a little bit about the iPhone application. If an iPhone is connected here, you're going to run through the exact same tests in setup, network, forensics. It's not until you get to the code analysis tab that you're actually going to see some differences based on just the way that the applications are developed. So one thing that's different is that the keychain is searched within the iPhone. So we do a keychain dump and we decrypt all of the usernames and passwords and everything that is stored in the keychain, and we display that information for the code analysis for the iPhone. You can see that these searches actually take a long time, and this is actually one thing I wanted to point out is the benefit of putting those keywords up in the search criteria. Doing the searches that way is much easier and more efficient than manually searching for, 5, 6, 7 different keywords within this search option here, since that file is so large. We do have it time out after 60 seconds because we do not want the application or the virtual machine or your computer even to crash. So just keep that in mind that using the search criteria within the setup is a much more efficient option. Okay, so that's memory dump. Exported activities. This is one thing we test in every app that we look at. By clicking on any of these activities, you can launch that activity on the device without actually having to click on anything on the device. So one example of this is I tend to use banking examples because that's something that people care a lot about. One banking application that we actually looked at, you were able to launch I believe it was like a view accounts activity. And you can launch that activity and it would display within the app the accounts on the device without the user actually having to log in or authenticate first. So that's something we always test is, can we launch an activity to get access to sensitive data without actually logging into the app itself? I'm going to show an example here. Let me pull up the app. We'll try the gift activity. Okay, so by selecting that, I can go to screenshot here and show you guys what I'm seeing on the device. When I clicked that button, it launched the gift activity on the device here. It did not do that without authenticating in this case, but just something that you might want to keep in mind if you ever get around to testing something like this is attempt to launch those activities prior to authentication. Finally, the SQL injection step is, it's not SQL injection as you might be thinking, it's for content providers within the Android application only. So this is just a feature with Android, not iOS. And here we can see on the left-hand side, after we ran this is the content provider that we found. And, here is the content provider that we found. And it looks like one of them was vulnerable to SQL injection. So it says that if you are using data within queries that are submitted to a SQLite database or a content provider, that SQLite injection may be an issue, and that was found to be an issue in this case. That wraps up our code analysis section. The last piece here is we just provide a remote shell into the device. So if there's anything that was not performed in the automated test and maybe you wanted to look at, one big thing that we like to look at is there anything stored on the SD card? Again, this is strictly for Android, but in the Forensics tab, we're just recovering what's on the device. So if you don't want to go through the effort of removing the SD card and connecting it and analyzing it, you can simply navigate to the SD card on the phone and start listing different things here. I know for a fact that for this particular application, nothing is stored on the SD card. It's stored all on the device itself. But by navigating through this folder structure, you can look and see what's stored there, among any other runtime analysis tests that your security analyst might be aware of to perform on the Android. Again, doing the comparison with iPhone, since I'm not demonstrating that today, we provide either a remote shell into the file system of the phone, or you also have the option to run a Cycrypt shell to perform advanced runtime analysis attacks. On the other tab here is PCAP. And while we do an automated packet capture earlier on during the data population process, this allows the analyst to start and stop a PCAP at any point during the assessment. You don't have to go back up to setup and run through the keyword searches and all that. You can simply start and stop your PCAP file, and it will be created under Networks and Artifacts. And then at that point, another good example of how a security analyst could dig a little further into something as opposed to maybe just a developer running automated tests, you can click View in Wireshark and run your own manual searches or tests there. Finally, we're onto the report editor. By default, everything that was populated on the left-hand side is going to be listed in each of these sections here. If you wish to exclude any of these, you can uncheck. Go through these. As I mentioned earlier, you can move things to the appendix if you want to save room in there. I'm going to go ahead and go to Forensics here. Those are our manual findings and results that we added. And then there's all of our code analysis. When you're ready, you can click Generate Report, and it's going to generate this report for you, which can be saved in a number of formats. We have PDF, HTML, XML, and JSON. And this report just provides really a summary of everything that you saw on the screen there. It's going to show the summary of all the findings, highlighted as low, medium, high risk, or a pass. It's going to tell you a brief description of that item, and then the section that you can find the details in. As you scroll down a little more, you can find each of the details of the findings are going to have a description of that finding, a recommendation on how to fix, and we've also mapped each of those automated findings to a CWE or more, one or more, or the OAuth Mobile Top 10. One thing I didn't show you is that you can rearrange the order of these findings that are displayed in the report. Quick show you that step. Let's say you want to put the search results at the bottom. You just drag it down to the bottom there, and it gets rearranged in the order you want it to be rearranged in. And that gets reflected in the report. That's going to conclude the demo. I'm going to switch screens here and see if I can review some of the questions you guys have submitted. We'll go through those, and then we'll finish up the presentation. Okay, one question is, how long does it take for a typical assessment? That is a really good question and something that we're very excited about. It takes, really running just the automated test normally takes about 20 to 30 minutes. But to do a fairly thorough analysis, you can estimate about 1 hour. As I mentioned, if it is a knowledge security analyst going through all the different artifacts and digging into the PCAP files and Wireshark and things of that nature, it could take, 2 to 3 hours perhaps, but it's a drastic decrease from the 60 to 80 hours that our team has spent in the past doing everything manually. It's really nice to have things already set up for you in this environment. Setting up a man-in-the-middle attack, performing the attack itself doesn't take very long, but setting up the network for that to happen can be time-consuming. The next question is, how much security experience is required for a person to use viaLab? That varies. I would say for anybody to use viaLab, you would want to have a little bit of security experience. But as you can see, just running through the automated tests alone, really anybody can see if there's any sensitive data stored locally in log files. You can test man-in-the-middle. You can do some basic code analysis, search memory dump. All of those automated tests can be done just by clicking a couple of buttons and does not really require a ton of knowledge. Now, we think it's more beneficial for someone who works with this kind of information every day. We think it's more beneficial for someone like that because they can not only run these automated tests, but they can go a little more in depth, and they can also validate these findings. So like I said, you can jump into the man-in-the-middle database, and you could look in and verify that it was in fact sending the username and password, and you can validate that that man-in-the-middle did actually fail the test. Okay, moving on to the next question here. It says, what types of searches does it do for usernames and passwords? Okay, so I think what that's getting at is with different formats. So we search for sensitive data in various formats in addition to plain text. So we search for base64 encoded. We search for hashed values, including MD5, SHA-1, SHA-256. We search for all these different values. So even if it's stored, let's say, in a plist on the iPhone as an MD5, we're going to find that and we're going to show it to you. It also automatically searches for all sensitive data in each of these different forms in all of the locations that we displayed there. So memory dump, log files, PCAP, SSL proxy, and probably some others that I'm forgetting right now. Okay, good question. does the application get transferred to the PC for testing, or does it remain on the target? We make a copy of the application and the application file within viaLab. We do not transfer it. So nothing gets affected on the device other than a simple copy of those files at various points in time. Okay. Another question we have here is, sorry, I'm just trying to review the questions as I'm reading here. If we would like to block certain interfaces or ports, for instance, USB test ports, how would it be possible to test it for security? That's another really good question, and I actually do not know the answer to that one. I can go back to our dev team and bring this information to them. This goes for this question and any others that I'm unable to answer for you today. I can take this information back to our dev team, and we can get back to you on that. Okay, does your tool have the ability to distinguish potential actual social security numbers and credit card numbers, or is the result based on format and or number of digits? The latter. Right now it's just searching for that format. It's pretty easy to dig into when we provide the source of that information, so wherever it finds that search criteria, we can dig into the source, and it's pretty easy at that point to decipher whether or not it's valid or not. For example, you'll see, surrounding context, and if it says credit card next to it, then you'll know it's a credit card number. Otherwise, if it's just a bunch of characters, then it's also if there's a bunch of characters, then it makes it pretty easy to exclude that as an option. Yes.
Hey, Katie, this is Ted. I just want to jump in here. If you know the card number that you're testing with, you can also enter the actual card number that you're testing with and have it search on that and match on the actual card number. So in that case, it would distinguish, obviously, with accuracy. You could put in, a few variants of that actual card number or partials of it just to match that versus using the format.
Yep, good point. Thanks, Ed. Okay, the next question is, does it just detect vulnerabilities or does it also attempt to exploit them? In many cases, we actually do attempt to exploit them. So content provider SQL injection is one example. Man in the middle and SSL strip is the actual exploit. And in those cases and a couple others, that proves that the vulnerability is actually susceptible to actually attacking in those scenarios. I'm not seeing any other questions. Oh, looks like one just popped up. Okay, yep, we just got another one. An iPhone and an Android phone are provided with viaLab. Are the analyses limited to those particular hardware OS versions, jailbreaks, etc.? Short answer is yes. Right now, we have certain versions that we know work. We by default sent an iPhone and an iPad, but we successfully tested an iPad. Did I say iPad? We said an iPhone and an Android by default, I should say. But we have successfully tested an iPad to work. So if your company or organization tests iPad applications over iPhone, that is an option. And right now we have them running on multiple versions, and yes, it is dependent on whether or not the device can be jailbroken or rooted. So I hope that answers the question. Okay, so here's another question. I remember seeing a window where one can select various compliances such as ISO, HIPAA, etc. What specifically would the test software look for? We don't actually look for anything in particular. We just kind of flag that item with that certain compliance. So if it is a HIPAA item, it would be flagged in the report. Okay, and I think that's all the questions we have. I'm going to go ahead and cut that off now. And, oh, I just found another one pop up. Just like launching Android activities, is it also possible to launch individual iOS screens to see if any information can be accessed without login, or is it limited to Android? Right now, it is just limited to Android. It's a little bit more difficult, I should say a lot more difficult to automate some of the runtime analysis that we do in iOS. Like I mentioned, we do provide a Cycrypt shell into the device, and if you jump into the Help menu within viaLab, I can do that right now really quick. We do have a Cycrypt, a couple examples of what you can do using Cycrypt within the advanced section. Sorry, I'm in the wrong section here. There we go. So we talk a little bit about Cycrypt. We provide a link out to how to use Cycrypt. It's really a powerful tool, but it does require quite a bit of experience and knowledge to use. So it's hard to automate these things, but we provide the means to do that within viaLab. Okay, I think that's all the questions we have right now. Get back to the slides here. That concludes the demo. Our next webinar is actually going to be in 2 weeks on September 5th, and it's going to be on mobile forensics challenges on iOS and Android. I believe in the invite that you got today, the link was provided to register for that if you're interested. Otherwise, please feel free to contact us for more information on that. I will provide the contact information at the end of the webinar here. Also, we really do appreciate your feedback and suggestions for future topics. We have a survey form that once we get this PDF posted, you'll be able to click on that link. And I believe Kevin has also provided in the chat window a link to that survey. We really do appreciate that feedback and look forward to any suggestions that any of you might have. Here's my contact information. If anyone wants to contact anybody else at viaForensics, you can contact that main number and email us, join us on Twitter, or just visit our website for any details. Thanks everyone for joining. Hope to see you in a couple weeks.